All right, so in the last lesson we did box and whisker plots, and I told you, hey, box and whisker plots, I've never used them in real life. Now we followed up with standard deviation, which I have used in real life. This is one of the biggest tools in statistics. Standard deviation is huge. We're going to barely touch on it today, but this one has big application in real life. I used this one when I was an engineer. So goal, I can use statistics to help me understand the world around me. Why? More complex statistical methods are used in engineering, finance, and medicine. I want to understand how statistics can be used in real life. The world is going to lie to you. It's going to lie to you using statistics. The newspapers, the magazines, the internet, they love to throw around things like averages and means and stuff. We've already talked about mean, median, and how those values can be skewed or used. So today, you're going to learn a new statistical method called standard deviation. The standard deviation will give you more insight into the mean. The standard deviation will help you not to be lied to, or at least not as easily lied to. So I'm going to actually show my face here for a second. Am I showing a face? I'm almost showing a face. All right, I'm talking to the camera now. I'm slouching, so I'm actually on the camera. Okay, so here's the deal with standard deviation. If I got a whole bunch of really big numbers and a whole bunch of little numbers, and I average them, like let's say I've got a whole bunch of hundreds and a whole bunch of ones, and I average them and I get a 50, right? Well, what if those are salaries? I've got a whole bunch of people making $100,000 a year. I've got a whole bunch of people making $1,000 a year. I average it, and it makes it look like everybody's making $50,000 a year, and we're all happy. Well, no, we're not all happy. That's kind of crazy. You got a bunch of people making a bunch, and you got people not making much, and you got nothing in the middle. The standard deviation is a way to figure out that there's nothing in the middle. It's a statistical tool that's really going to show us how tightly packed the data is. So if I've got values at 100 or 101, and I've got these big values and these little values, the standard deviation is going to be really, really big. But now let's say I survey a bunch of people and they're all telling me they make 50,000 a year, right? 50,000, 50,000, 50,000, 50,000, 50,000. Now the standard deviation is going to be really, really small. It's going to be really tight. So the standard deviation tells us how spread out the data is. And that's a good thing to know, because just having the average or the mean doesn't tell us that much. If you give me the average and a standard deviation, I can tell you, oh, the data is really tightly packed or the data is really, really spread out. That's the value of the standard deviation. And when I was an engineer for Boeing doing production work, we used the standard deviation to tell us basically how tightly packed our production was. Were we getting things out very, very quickly, or did we have some parts that were taking forever to come out and some parts were coming out quickly? So it showed us how tightly packed our production numbers were. All right, let's show you how to do this. All right. I know, Mr. Barr gets too excited about standard deviation. Let's take our notes. Calculating standard deviation. Standard deviation. Two classes took a recent quiz. There were 10 students in each class, and each class had an average of 81.5. Yeah? Since the average are the same, can we assume that the students in both classes did pretty much the same on the exam? Answer to that is no. Like the example I just gave you with money, just having the mean doesn't tell us everything. The average mean does not tell us anything about the distribution or variation of the grades. It doesn't tell us if the grades were really spread out or if they were really tightly packed. Here are the dot plots of the grades in each class. Notice both of these have the same mean, but the top one, we can see that the grades are tightly packed, and down here, the grades are really spread out. Standard deviation is going to tell us about how tightly packed something is. So we need to come up with some way of measuring not just the average, but also the spread of the distribution. It's Mr. Best! Let me pause my video for just a second, and then I'll come back. All right, and I am back from talking to Mr. Best. So we need to come up with some way of measuring not just the average, but also the spread of the distribution of our data. We need to figure out, is this data tightly packed or is it all spread out? And the standard deviation is the number that measures how far each number is in a set of data. So we're going to put that into our notes. The standard deviation, I'm going to paraphrase this a little bit. It tells us how tightly packed the data is. Back to the notes. That's not it. All right, so we're going to calculate a standard deviation. A big standard deviation tells us the data is really spread out. A smaller one tells us that the numbers are close to the mean. So big, really spread out. Small, really tightly packed. So here's our set of data, and we're going to do our standard deviation. So our numbers are 72, 76, 80, 81, 83, 84, 85, 85, and 89. And we're going to calculate the standard deviation for this set of data. First thing I need to do is I need to calculate the average of this data set. So 1, calculate the average. Can I put it right here? You know what, I'm going to have to go to another page because I'm going to run out of space here. So step 1, find the average. I'll be flipping back to that page. Okay, so coming back here, I need to find the average of that data set. So I add up all the numbers and I divide by the number of numbers, and I get 81.5. What I'm going to do is I'm going to write that average next to each of these numbers. So I have my data, I have my average, which is 81.5. I'm now going to calculate the deviation. If this is a middle of the road, if you're driving down a road and you start going off the road, we call that deviation. You're deviating from the path or from the road. So each of these numbers in the data set has deviated from the average. Each of these numbers have gone off that middle road. So we're going to calculate the deviation for each value. Now, I don't care if it's positive or negative, and you'll see why in the next step, but I'm going to do 81.5 minus 72. That's 9.5. So the deviation here is 9.5. 72 is 9.5 off that average. Or if this is the middle of the road, 72 is 9.5 feet off the road. I would do it again, 81.5 minus 76, 5.5. Now, yes, this is a negative, but it's not going to matter. So step 2, I calculate my deviations. So I calculate the deviations for each value. And I probably have this calculated, 7.5. There we go. So I'm going to get this into my notes. I'm just going to copy it so I don't have to calculate each one. Minus 1.5, minus 0.5, 1.5, 2.5, 3.5, 3.5, 7.5. So if this is the middle of the road, this one went to the left 9.5 feet, and this one went to the right 7.5 feet, the deviations. Next thing we're going to do is we're going to take each of these deviations and we're going to square them. Deviation squared. This is why the negative doesn't matter, because when I square a 9.5 or I square a negative 9.5, I get the same thing, 90.25. So I'm going to square each of these deviations. So this is step 3, square each deviation. All right, so I do 5.5 squared. That would give me 30.25. And I would just keep going and square each of those deviations, and I'm just going to pull that up right here. So there are all the deviations squared. 30.25, 2.25, 0.25, 2.25, 6.25, 12.25. So I just squared all the deviations. Next, I'm going to take the average of the deviation squared, which means I'm going to add up all these numbers and I'm going to divide it by the number of numbers. So find the average of the deviation squareds. So coming back to this, I'm going to take the average of these numbers. So let's start by totaling it. So the total here is 214.5. And we're going to divide that by 10, which is going to take me to 21.45. 21.45. This is not the standard deviation. This is called the variance. So find the average of all the deviation squares. This is the variance. So how do I get the standard deviation? I take the square root of the variance. So in this case, we're going to do the square root of, what was it, 20 point something? 21.45, which equals 4.6. And you get to learn a cool symbol. This is called this is the standard deviation symbol. It's also called sigma. So in this case, sigma equals 4.6. It's called sigma because this is the Greek letter sigma. Just like we have letters A, B, C, you've got alpha, beta, kappa, gamma, delta. It's a Greek letter for sigma. It's a lowercase sigma, I think. All right, boom, standard deviation. That's how you do it. So how do I do it? I find the average of all the numbers. I calculate the deviations using that average. I square each deviation. I find the average of all the deviations. At that point, I have the variance. I take the square root of the variance, and I get the standard deviation, also called sigma. Boom. So for the first set of data, our sigma was 4.6. So for this top set of data, our sigma is 4.6. For the bottom set of data, using the exact same method, it's 15.1. So when we look at this, a 4.6 standard deviation tells us the data is really tightly packed. The 14 point whatever, was it 14.1? 15.1. The 15.1 shows us that the data is really spread out. So if we're talking about income distributions, okay, not making any political claims here, people. So just, not making political stuff. But if the goal is to have a really strong middle class in a country, you want a really small standard deviation. You want the data to be really, really tightly packed. You expect most of the people to be right around there in the middle. When we look at, I guess, income data, if we've got really, really big standard deviations, that means that the data is really, really spread out. I don't know. Not making political things here. Just want you to think about how standard deviation can be used in real life. So with test scores, I'd rather have a really tight standard deviation. I want most of the scores to be right around the same region. You know, I'd like to have like an average test score of 80 with a standard deviation of 3, as opposed to an average test score of 80 with a standard deviation of 20. I don't even know if that's possible. Okay. Hey, I think that's it for this lesson. Go do some practice. Just keep those notes right there in front of you and follow the method I just gave you. Thanks for watching. Stop.